The IMDG code was developed as an international code for the maritime transport of dangerous goods in packaged form, in order to enhance and harmonize the safe carriage of dangerous goods and to prevent pollution to the environment. The code sets out in detail the requirements applicable to each individual substance, material or article, covering matters such as packing, container traffic and stowage, with particular reference to the segregation of incompatible substances. The International Maritime Dangerous Goods IMDG code is available in a 2-volume set. Volume 1 of the IMDG code includes general provisions, definitions, training, classification, packing and tank provisions, consignment procedures, construction and testing of packagings, intermediate bulk containers, IBCs, large packagings, portable tanks and road tank vehicles and transport operations. Volume 2 of the IMDG code includes limited quantities exceptions, an index and appendices. Together with the IMDG code, the IMDG supplement is necessary for full implementation. This supplement includes important details of methods for the packing of dangerous goods and emergency procedures to take in the event of accidents involving workers who handle dangerous goods on board vessels. The IMDG supplement includes an emergency schedule, EMS, guide, a medical first aid guide, reporting procedures, regulations for packing cargo transport units, regulations for the safe use of pesticides and irradiated nuclear fuel, INF, code. The IMDG code categorizes dangerous goods into 10 groups including explosives, gases, flammable liquids, oxidizing substances and organic peroxides, toxic and infectious substances, radioactive material, corrosive substances, and miscellaneous dangerous goods and substances. Class 1 is the hazardous material classification used in the transportation of various explosive substances. The classification is further divided into 6 divisions, each with specific characteristics and safety requirements. Class 2 dangerous goods are gases. It covers compressed gases, liquefied gases, dissolved gases, refrigerated liquefied gases, mixtures of gases, and aerosol dispensers or articles containing gas. There are 3 subdivisions. Division 2.1 is flammable gases. Division 2.2 is non-flammable, non-toxic gases, and Division 2.3 is toxic gases. Class 3 dangerous goods are flammable liquids with flash points no more than 60 Celsius degrees. It covers liquid substances, molten solid substances with a flash point above 60 Celsius degrees. Class 4 dangerous goods include flammable solids, substances liable to spontaneous combustion and substances which, in contact with water, emit flammable gases. There are 3 subdivisions. Class 5 dangerous goods are oxidizing substances and organic peroxides. There are 2 subdivisions. Division 5.1 is oxidizing substances and Division 5.2 is organic peroxides. Commonly transported Class 5 dangerous goods include hydrogen peroxide, potassium permanganate, sodium nitrite, ammonium nitrate fertilizers, and oxygen generators. Class 6 dangerous goods are toxic substances and infectious substances. There are 2 subdivisions. Division 6.1 is toxic substances, and Division 6.2 is infectious substances. Commonly transported Class 6 dangerous goods include cyanides, lead compounds, phenol, creosoles, some pesticides, biological samples, and clinical wastes. Class 7 dangerous goods are radioactive materials. Commonly transported Class 7 dangerous goods include enriched uranium, radioactive ores, isotopes, and some medical equipment or parts. Class 8 dangerous goods are corrosive substances. Corrosive substances may cause severe damage when in contact with living tissue such as skin or damage or destroy surrounding materials in case of leakage. Commonly transported Class 8 dangerous goods include acids such as sulfuric acid, strong bases such as sodium hydroxide, batteries, and its fluids. Class 9 miscellaneous dangerous goods are substances and articles which during transport present a danger or hazard not covered by other 8 classes. This class encompasses, but is not limited to, environmentally hazardous substances, substances that are transported at elevated temperatures, miscellaneous articles and substances, genetically modified organisms and microorganisms. Commonly transported Class 9 dangerous goods include marine pollutants such as zinc oxide, lithium-ion batteries, genetically modified organisms, airbag modules, and motor engines. At the end of Volume 2 of the IMDG code, there is an alphabetical index of substances or articles. This can be used as the initial point of reference when the name of the substance rather than the UN number is known. In the IMDG code, most of the decisions on safe shipping and transport procedures stem from the use of the dangerous goods list located in Volume 2. The DGL is an index of substances and articles arranged in UN number order. It comprises 18 columns of information for each listed substance/article, presented as a 2-page spread in the printed books. Much of the information is in a coded form to make it easier to present in a table. Let's consider a product listed as chlorine trifluoride. We look up the name in the alphabetically listed index. We can see chlorine trifluoride belongs to class 2.3 and has UN ID 1749. We enter the numerically listed dangerous goods list in Volume 2 with the UN ID. Information about chlorine trifluoride is displayed across the 2 pages. A generic segregation by class table, found in Section 7.2.4 of the IMDG Code Volume 1. The boatmaster needs to know if the classes of dangerous goods can go in the same cargo transport unit, CTU, or if they will have to be placed in separate CTUs so they can be stowed in different areas. To determine the segregation for 2 classes, you would read a row for one class, across, and for the other class read a column, down. Where they intersect, you will either find the letter X or a number. The numbers, 1, 2, 3, or 4, will tell the people stowing the goods how far apart they must be separated. Let's see if you could ship a flammable gas such as UN 1978, propane, in class 2.1 in the same CTU as UN 1203, gasoline, a flammable liquid. We find the compatibility in this case by reading across for class 2.1 and down for class 3. There is a number 2 where the row and column intersect. This means that the goods must be separated from each other. Separated from means the cargo transport units should be at least 6 meters apart. We cannot put these 2 products into the same CTU for an IMDG shipment. Let us consider a shipment of a hand sanitizer based on UN 1170, ethanol, class 3, with UN 2555, nitrocellulose with water, class 4.1. We'll look at class 3 as a row going across, and class 4.1 as a column going down. In this case, there's an X where the row and column intersect. This means that there is no automatic segregation between class 3 and class 4.1 materials. If the segregation table does not indicate any automatic segregation between the classes, we have another step to take. We have to check these specific substances to see if there is any other compatibility issue between them beyond the generic class compatibility. We have to go to the dangerous goods list in Volume 2 of the IMDG code, and check column 16B, headed segregation. In this column, we can find 2 sorts of codes, SG codes for segregation, and SGG codes for segregation group. These will give more guidance regarding segregating specific substances and articles. Here, column 16B is blank. That means UN 1170 doesn't have any specific extra segregation requirement. When we look up UN 2555, nitrocellulose with water, we have 2 codes in column 16B, SG7 and SG30. To find out what these codes mean, we must go to IMDG code section 7.2.8, where they explain what these segregation codes represent. SG7 means that this product needs to be segregated away from class 3 materials. In other words, it's as if there were a 1 between these specific substances on the generic segregation by class table. These substances cannot be placed in the same CTU, even though the generic table indicates there is no specific segregation by class, since the segregation code demands these two specific products be segregated. The segregation group codes apply to certain families of chemicals, regardless of their class. These chemical families will have special additional segregation requirements. The table can be found in section 7.2.5.2 and covers 18 common chemical families that can cause dangerous reactions. For UN 2555, the chemical must be segregated from anything placed in the segregation group SGG7, heavy metals and their salts.